Alright, so today's lesson is on parameter changes of exponential functions. So recall that this is an exponential function because the x is in the exponent. It's also growth because our b value is greater than 1. Our parent function is going to be y equals our base raised to the x power. That's important to know when making a table for our transformed function. So what we want to do is we want to always start with the parent. So we're going to go ahead and make a table for our parent. Okay? And the 3 points that we're going to use are going to be we're going to start with -1 for our x, 0, and 1. These are the 3 points we're going to be starting off with. So the y-coordinate with the -1 is going to be 1 over b. So I'll put that off to the side over here, 1 over b. So here our base is 3, so our y-coordinate is going to be 1/3. Okay, the y-coordinate with the 0 for our parent is always going to be 0, 1. And then our y-coordinate for the 1 is just going to be our b value, which in this case would be 3. So, mathematically speaking, if we plug -1 in for x, we get 1/3. If we plug 0 in for x, we get 1. And if we plug 1 in for x, we get 3. And there is our parent table. Now, to get our transformed table, we're going to have to do the transformations. So let's start off with the y. So the first thing we notice here is we're multiplying by -2. So we're going to multiply. I'm going to use parentheses to signify multiplication, because that is a vertical stretch with a reflection over the x-axis. So both of these are going to be affecting the y-coordinate. And the +4 will also affect the y-coordinate. Next, what about the x-coordinate? Well, up here we have x minus 1, which means it's translated 1 unit to the right. So remember, your x always lies, so we're going to add 1. So let's quickly do the math here. So 1/3 times -2 is -2/3. And then -2/3 plus 4 is going to be 3 1/3. -2, 2. -6, -2. On the x side, adding the 1. All right. So now we have our coordinates, our new y's, and our new x's to graph. So let's just start by plotting our parent just to see what it looks like. So we have -1 and 1/3, 0, 1, 1, 3. And for our parent function, our k value here is 0. Oops, sorry about that. Let me scoot over here. Our k value is 0. So there's no vertical translation going on here. So our horizontal asymptote is going to be y equals 0, which is going to be our x-axis all the way along here. That's our asymptote. So when we draw this curve, we're going to go along the asymptote, curve through those points, just like that. Okay, now let's do our transformation points. So we have 0, 3 1/3, 1, 2, 2, -2. Okay, so as of right now, you might be a little confused on why this looks the way it does. Well, before we start sketching this, let's go ahead and draw in our asymptote. So in this case, our k value is 4, which means our horizontal asymptote is going to be y equals 4. So 1, 2, 3, 4. Okay, that's our horizontal asymptote. It's always related to k in the function. It's always related to the k value. So now we can draw this. We know that we're going to go underneath the asymptote, so we're going to go along the asymptote, and then we're going to curve it through those points, just like that. Okay, let's write our domain and our range. So our domain is going to go infinitely left and infinitely right. And then our range is going to go infinitely down, always lowest to highest, and up to 4. But since this is an asymptote, it's not going to cross it. It's just going to get really, really close to it. So we're going to use parentheses and not a bracket. And then finally, let's write down the transformations. So first of all, the negative is a reflection over the x-axis. Reflected over x-axis. So that means this parent flipped down. Now you can see why it's looking like this, because this has been reflected over the x-axis. There's been a vertical stretch because our a value is greater than 1. And we are translated 1 unit to the right. And translated 4 units up. And that's how you get your transformed graph. These are the transformations. Remember, parameter. When you see the word parameter, you should think A, H, and K mainly, and sometimes B. And remember, B is your horizontal stretch or compression, and that would be on the X here. Okay? All right. So, there are your notes. If you have any questions, please bring them to class tomorrow. Thank you.